All right, we're talking about section 7.3 today. All right, let's get started, guys. We're talking about prism or pyramids today. We're going to get our formulas for surface area and volume. So the first thing we need to know is what makes a shape a pyramid. It can be, our base can be a square. So let's start off with our parts of our definition. Our pyramids are polyhedrons. And it has all of these different things. A base the base is a polygon. So the base can be any polygon. Doesn't have to be a square, doesn't have to be any particular shape. The base can be any polygon. It has to have 3 or more and we have to have 3 or more because the smallest polygon we have is a triangle. So 3 or more lateral faces. And remember, lateral faces just mean sides. Lateral just means side. And our lateral faces are triangles. So these are the two things. These two things are what make our polyhedron a pyramid. It has a base that's a polygon and 3 or more lateral faces or sides, which are triangles. So let's draw a picture. Get a picture of a pyramid here and label some parts. And we'll start off with a triangular pyramid. And pyramids are like prisms. We name them by the shape of their base. So the tip, the point here where our lateral faces come together, is the vertex. Or if you want a shortcut for drawing pyramids, just draw whatever shape is your base, and then draw a dot up here, and then connect that dot to each of your sides, and you'll have a pyramid. So our tip is a vertex. This is a lateral edge. Down here we have a base edge. The triangle down here at the bottom is our base. And this is a lateral face or a side. So our lateral faces are triangles. For this particular pyramid, our polygon that's our base is a triangle. The edges down here at the bottom are base edges. These edges are lateral edges, and the top is the vertex. Questions on that so far? Well, there's one other important part of a pyramid that we need to know to use our formula. So let's draw another picture, and I want to make it bigger so we can label the parts nicely. So let me grab another pyramid. And we'll use a square pyramid this time, just to make it a little easier to see. And we'll make this nice and big. The distance, or the segment, from the vertex, and that makes a 90-degree angle with the base, is called the altitude. And that's how we find our height. But we need one other segment for our formulas for a pyramid. If we go from the vertex at a 90-degree angle to the base edge, this segment is called the slant height. That's how we find the slant height. So the altitude is from the vertex to the base at a 90-degree angle, and the slant height is from the vertex to a base edge at 90 degrees. So we'll need these different parts in different parts of our formula. I just want to make that look a little better. Questions on that drawing? All right, let me add one other bit of information because we need to know just a little bit more before we write our formulas. A regular pyramid. So we've been talking about some formulas work for regular shapes and some work for any shape. What makes a regular pyramid special is that it has a regular polygon as the base. So the base is going to be a square. The base is going to be an equilateral triangle. It's going to be a regular hexagon, something like that. So all the sides and all the angles are the same. And the lateral faces or we can call them the sides, are congruent isosceles triangles. So all of our sides are the same size, the same triangles. And one other thing, the altitude hits the base at its center. So that is what makes a pyramid regular. All right, so this is what makes a pyramid regular. We have a regular polygon for a base. Our sides are congruent isosceles triangles, and our altitude hits the base at its center. So let's get to our formulas. The surface area of a regular pyramid. So our surface area formula only works for a regular pyramid. And the parts that we need are slant height, we use the script L for slant height. P is the perimeter of the base. And B, capital B, is the area of our base. So our surface area, S, capital S, is 1/2 LP plus B units squared. Anybody have a guess as to why we have this 1/2 in our surface area formula? Mm-hmm.
Because when you find the area of triangles, you have to divide
Right. So Haley says when we find the area of a triangle, we have to divide it by 2. All of our sides, all of our lateral faces are triangles. So we're adding up the areas of all those triangles. That's where this 1/2 comes in, because our sides, our lateral faces are triangles. Now notice in this formula, in all the formulas that we've used so far, we have to find the area of the base. So all of our area formulas from chapter 5 that we learned before are going to be important in this unit. We have to be able to find area of different shapes to find the area of our base. So whenever we find the surface area, we need 3 things. What we have listed here, we have to find the slant height. If we don't have the slant height, we have to figure it out. We have to have the perimeter of the base. If the problem doesn't tell us the perimeter of the base, we have to figure it out. And we have to have the area of the base. So if we don't know that, we have to figure that out. So let's do an example of calculating with this formula, and then we'll get to our volume formula. And then I'll give you an important shortcut for pyramids. We have a book that we're going to be get in the next couple of days. A flip book. So we have a regular. Let me draw a picture here. We'll draw this one as a picture. So here's my pyramid, and we're going to say this is a regular square pyramid. And I'm going to put my vertex right up here, and then put the sides in. And we'll put this in. And we'll label our parts. This is 6 centimeters by 6 centimeters. And this is 5 centimeters. And we want the surface area. So we need to find, whenever we find our surface area, we need our slant height, perimeter of a base, and the area of the base. So what's our slant height here? L equals 5 centimeters. So we have that part. Let's find P. What's the perimeter of our base? 24. It's a square, so we have 4 sides. Each one is 6, so 6 times 4, or 24 centimeters. What's the area of the base? 36, 6 times 6. So now I have all the parts for my formula. The surface area is 1/2, 5 times 24 plus 36. And if I add that, calculate that out, and add it all together, it turns out to be 96 centimeters squared. So the surface area of this pyramid turns out to be the same as the surface area of our prism that we started with. Any questions on that part? And if we, another way you could do this with pyramids, it's kind of nice. If we drew a net for this pyramid, pyramids are usually pretty easy to draw a net for. Our net would look something like this. And we know that all of these are 6, and this is 5. So we could draw our net. We could draw our net and add up the areas of all the pieces, and we should end up with the same answer. So pyramids, if you can't remember the formula or not sure how to work the formula, you can always draw a net and calculate it that way. You can do that with any of the shapes. Pyramids are nice because they're easy to make nets for. All right, let's talk about our volume formula. So our volume formula works for any pyramid. For our volume formula, we need B is the area of the base, and H equals our height. Our volume, anybody want to guess what our volume is? So here I have a rectangular prism, and here I have a, they come in a kit. So there I have a pyramid. So is the volume of the pyramid, if it had the same base and the same height, is the volume of the pyramid going to be less or more than the prism? Less. Anybody want to guess how much less?
A lot less.
Half? Pretty good guess. Turns out that the volume is 1/3 the area of the base times the height. So the volume of a pyramid is 1/3 the volume of a prism with the same base and height. And we could write this as area of base times height divided by 3. So it's 1/3 the area of a prism with the same base and the same height. And our units are going to be units cubed, always for volume. So let's do an example of a calculation with the volume formula, and then I want to show you an important shortcut with pyramids. So in this example, we have a regular square pyramid. The height is 112 feet. And a base edge equals 99 feet. And we want the volume. Now if the problem gives you numbers, it can be very helpful to draw a picture. So I have a regular square pyramid. So I'm just going to draw a sketch here. My base is a square. So there's my pyramid, and my height, I'm just going to sketch it in here, like so. It's not a perfect drawing, but we get the idea. That's 112 feet. And the base edge is 99 feet. So that's what our pyramid looks like, except since it's regular, my height should go to the center of the pyramid. Just because my drawing is not great. So for our volume, we need the area of the base and we need the height. Well, we know the height already. What's the area of the base? How are we going to find the area of the base? 99 times 99. The problem tells us it's a square pyramid, so the base is a square. So the base is 99 times 99, which when I multiply that out, I get 9801 square feet. And we know the height is 112, so our volume is 1/3 9801 times 112. And that equals, when I calculate that out, 365,904 cubic feet. Any questions on that? All right, let me show you a very important thing that you're going to need to remember about pyramids. So let me get a picture here, and we'll get a nice big picture again. This is going to be a relationship that you're going to need to remember for pyramids. It's going to come up a lot in problems and possibly on quizzes and tests. So let me make it nice and big. And let's draw in the altitude and the slant height. So there's my altitude. This is how we find our height. And that makes a 90-degree angle with the base. And let's draw in our slant height. And this makes a 90-degree angle with the side. Now I'm going to draw in one more piece. I'll draw this one in green. And we're going to say that this is a regular pyramid. So if this is a regular pyramid, and this is a 90-degree angle here, this triangle made by the red, the blue, and the green segment, what kind of triangle is that? This is a right triangle. This angle is 90 degrees here. The slant height is what part of the triangle? That's the hypotenuse. And if we have a regular polygon as the base, this distance from the center to the center of an edge, anybody remember what that segment is called for a regular polygon? This is the apothem. So if we have any two of these parts, the red segment is the height, gives us the height. The hypotenuse is the slant height. So the hypotenuse of our right triangle is a slant height. The base of our right triangle is the apothem, and this side is the height of our pyramid. So if we have any two of these pieces, we can find the third piece. So a lot of times your problem will give you, you'll have the slant height and you'll be able to figure out the apothem, but you don't know the height. You have to use the Pythagorean theorem. So when you have these parts, you should think A squared plus B squared equals C squared. Because when you have a pyramid, you always have this right triangle. So for example, if this were a regular square pyramid, and we knew the side length, say, was 10 centimeters, how long would the apothem be? 5. It's half. So if we have a nice square, we know that this apothem is half the total width of the square. If we had a regular hexagon, and we knew the apothem, we would be able to figure out the other parts using that right triangle. So it's important to remember, with a pyramid, you have this right triangle here that you can work with using the Pythagorean theorem. That little trick comes up a lot working with pyramids. All right, any questions? Okay.